Good afternoon. I'm Joe Swartz with American Hydroponics. And today we're going to do a short webinar on tips, tricks, and tools of the trade. Basically, we offer informational seminars and webinars, and we have a lot of information that goes out on our LinkedIn forum. But today we have a lot of people that ask questions as a grower, little tricks and little tips of things that can help you that you don't normally read in a book or get from informational seminars, but more like information from growers who are actually doing it. So what I'd like to do today is address a lot of questions and concerns that many of you have raised with us and run you through the basic system. So if you have questions, you notice on the webinar webpage, you can send in questions. Please feel free to send us some questions. I can address them here live. We also, on our website, AmHydro.com, we have a chat feature, so feel free to come and talk to us at any time. But today we'll just talk about a few things that, if you're a grower or a new grower, may help you out to make your lives a little bit easier. So basically, we'd like to start first with workspace. In a production greenhouse like you see here, we're in our HCLE, Humboldt County Office of Education greenhouse. This is a greenhouse that we designed and built with the Humboldt County Office of Education for hydroponic and entrepreneurial training for high school students, and it's fully operated by them. So we'll be teaching a 2-day seminar here next week. It's a great space, and it's a great example of a small-scale commercial production system. So in a smaller scale greenhouse like this, you don't necessarily have to have a specific head house or area to do all of your other tasks that you normally are not associated with the inside production of the greenhouse. Your seeding, your maintenance, things like that. Large-scale growers always have a separate area from the production greenhouse. In a smaller space like this, obviously, you don't want to do that. So what we like to do is try to make an efficient space where you can do all of your seeding, all of your harvesting and packaging can be done in one area. So we encourage you home setup to experiment and find out what works best for you. What we like to do is look at the workflow. So if you have all of your maturing plants at the far end of the greenhouse, it doesn't make a lot of sense to have your harvest and packaging area up front. So look at the way your greenhouse is set up and look at your workflow and try to set it up. So basically what we have here is an area where the plants are brought up and harvested and packaged here. And then once that is done, the area is clean, and then they do their seeding here. So you can use the same space for multiple uses. We have different, we can definitely give you good ideas as to how to do that for your specific application, but by and large, you want to set up a nice, clean, organized workspace right from the beginning. So it's important to have things that you're going to need. We're going to talk about a few of them today. Organize them in one space. We have the HCLE students have all of their aprons and their work tools and their boots all in an organized location where they also keep their checklists and things like that. So all their supplies, really, really important to have. So again, having a space you can buy an inexpensive cabinet to store everything in, that's really, really important. Some of the things that you want to make sure you keep on hand, plant stakes. These are real important with every crop. You want to make sure you assign a number to each crop, both for food safety traceability, but also to be able to track your production, how long it spends in each growing section. So it's important to keep Sharpie pens, plant stakes, things like that handy at all times. So we always want to keep those in our cabinet where we can get to them. Log books, very important. This can be as exotic and sophisticated as high-level plant production software, all the way down to a spiral notebook. Most small-scale growers, literally in the greenhouse, keep a small notebook or a tablet where they just record their seeding, their transplanting, their harvesting. It's really, really an important tool to have, so you can follow the crop through all of the stages. Also, things like 5-gallon pails, trash cans, those are all things that we don't always think about, but those are really important to have because we want to keep a clean work environment at all times. So one of the biggest questions that we have from a lot of our growers is about seeding. Now there's a number of things that you can do with your seeding. Some growers use automated vacuum seeders. We do here with lettuce and individual plants. With some of the higher density greens, however, a lot of people with Oasis or rock will have to seed a large number of seeds per hole. In some instances, herb growers are growing basil, for example, with 4 to 10 seeds per hole. Now, to try to meter that out, that would be very, very time consuming and very difficult. So we have two methods that we've used in the past for what we call the multi-density or the high-density seeding that we do. So first of all, one of the easiest ways is we take our Oasis sheet and we take a pre-measured amount of seed. So what we've determined is if we want 8 to 10 seeds per hole in a sheet like this, we need about 2,000 seeds. So we painstakingly measured how many seeds fit into this Gatorade cap. And what that does is that gives us our set amount for one sheet of Oasis. Again, take the time to figure out a few of these things now, and then once that's done, you can move through the process pretty quickly. So what we found is we need our 2,000 seeds for this sheet here. So what we want to do is distribute them as evenly as possible into the Oasis sheet. So rather than actually trying to count out a number of seeds per sheet, what we'll do is we'll take this full amount and carefully, I hope you can see this well, and very carefully distribute it across the Oasis sheet as best you can. And we tend to start with a small amount and go back and forth over the seed. Literally, you can do a sheet of Oasis in 30 seconds. So if you notice, there's a fair distribution of seeds across the Oasis sheet. So now all we do is tilt it slightly and tap the Oasis sheet, and excess will either fall off or into the tub. Again, important to have a dry tub. We use Tupperware containers. Anything that's watertight that you can keep clean works very, very well. So we now collect all of the other seed, and that's reused. Here we have our seeded Oasis. So we'll take that to our propagation area. And before we do anything more with this, we'll address one other way to do high density seedlings. What we like to do is mix our seeds into a small amount of water. Now this is sweet basil seed, and what you'll notice is sweet basil seed, once it starts to take on water, will develop this gelatinous material on the outside of the seed. That's perfectly acceptable. That's very normal. Most seeds won't do that. However, any of our basil growers know that happens often. So what we do is we mix, again, a predetermined amount of seed into water. And we draw it up. You can use a syringe. Some growers even use a turkey baster. And again, determining a short squeeze, how many seeds will that put in the hole? Roughly 8 to 10. And then once you do that, you can very quickly move through and be seeding a pretty consistent amount in every hole. It beats trying to count out seeds, and it will speed up your seeding dramatically.
So Joe, we have a couple of questions.
Sure.
Some people have asked what kind of sheets, what are those that you're using there? And are there different types of that medium? And someone is using rock wool, but they'd like something biodegradable. Okay. Is there such a thing?
Okay, so what we're using here right now, these are called Oasis horticubes. These are a standard horticultural foam, probably the most widely used media in NFT hydroponics. We like it. Basically, it has very, very good air pore space and air holding capacity. It's a great media. Similar cubes are made of rock wool. They also make plugs that are cocoa fiber or peat moss, again, which are biodegradable. So it depends on your application. It depends on your use. The rock wool and the Oasis are not biodegradable per se. The Oasis foam is usually ground up by some growers and is composted. If you want a material that's specifically organic, we can go with the peat moss or cocoa fiber, which is coconut fiber plugs. So those are a couple of different options that you have. These happen to be, for our opinion, the most economical and effective material going. And so what we'll do,
since we score those?
I'm sorry?
Are you going to score them?
Are
you going to score the Oasis?
Yes, we're going to water it first.
Oh.
So what we're going to do is we are going to now after the oasis has been seeded, we're going to soak it down. Most growers have either watering cans, overhead sprayer. I only have a pitcher here handy, so that's what I'm going to use. But you'll notice what we're doing is we're soaking the oasis down quite heavily. This is actually more water than the oasis itself needs. What we want to do is we want to soak it through very, very thoroughly. This helps to fully saturate the growing media. And then what we want to do is we want to press it down just a little bit into our growing tray. That's going to help to make good contact with the bottom surface, allow for very, very even moisture distribution. One of the challenges that a lot of growers have is once the oasis is seeded and the seedlings are growing, when they're ready to transplant, they have to try to find a way to break open the oasis cubes. The oasis cubes are pre-scored, but they're still not, they don't separate completely. So what we always do when we seed, as soon as we're done seeding, we soak the oasis, we take a simple butter knife and we score them right on the pre-made lines. So that's really, really important. It makes it much easier when you have a strip of seedlings ready to transplant to be able to take them all out. So once they're done, they're fully soaked, but what we need to do now is we need to drain most of this water off. And this does two things. So all we're going to do is we tip up our tray. And what I usually do as a rule of thumb is that when we add water and soak our oasis, we want to then drain about 50 to 70% of the water that you added back out again. And people always ask, why do you put in so much water and then drain it away? Well, there's a few reasons. First of all, it's very, very important to thoroughly wet. As you notice, a good amount of the volume is back out again. So what that does is that thoroughly soaks the oasis. It coats the seeds with moisture, and then it allows, we don't want to have any dry spots into the oasis. So that allows us to make sure that we don't have any of those. But what we then want to do when we drain is as the moisture drains away from the oasis, what that does is that draws oxygen. It pulls oxygen back into the cube. And having a very, very well oxygenated seedling and having oxygen for germination is really, really important. And that's one of the challenges that a lot of growers have, is they have seedlings that they water down or seed cubes that they water down, and those seeds stay saturated and they don't get good germination and they end up getting poor growth. And poorly oxygenated seedlings also then tend to lend themselves to different types of fungal diseases, and that's something we can talk about in future time. So once these are done, they're ready to go into our propagation system for germination. So if we turn here, we can see this is our propagation system. This is just a simple AmHydro 412 system. And these are seedlings, lettuce seedlings that are just starting to come up now. Now this is a very, very important stage in the plant's growth, and we don't always spend too much time focusing on it, but it's very important. We want to make sure that these have the correct temperature and environment and nutritional support for growth. So one of the things that's very, very important with systems like this is bottom heating. A number of growers try to save money and they just put the system in the greenhouse. They don't supply any heat to the bottom and they get poor seedling performance. And one of the things that I always tell growers is to either take a small thermometer and actually stick it into your oasis like that, or use a small probe and leave it in your oasis so you can at all times tell what the temperature of your root zone is. For most plant varieties, you want to have a minimum root temperature of 62 degrees. So
we had another question, Joe.
Yes.
The question was it just plain water or nutrient water or something special?
That was water. That's pure water. We always soak our propagation cubes first with water. Once they've been soaked down with fresh water, then they're connected to a nutrient supply. We use nutrient solution. Some growers will actually feed the lettuce seedlings or germinate lettuce seedlings using nutrient solution. I don't think that's necessary, and sometimes a higher nutrient salt content will inhibit germination, so we tend to like to use fresh water for germination and then full strength nutrient solution from then on. So again, as we talked about, it's very, very important to maintain a proper rooting environment. Temperature is important, and air movement is also important, so having them in the main growing system is really important.
So there's another question. Is there a specific pH that you're trying to reach with when you do the water? Is there?
Yeah, and we'll talk about that with a little bit with nutrient solution. But with nutrient solution, it's very important to maintain a pH of somewhere in the range of 5.6 to 6.0. So we adjust the pH of that nutrient solution, which is for nutrient availability. Using water or adjusting the pH of water for germination is not as critical, although we like to use the same pH adjusted water. So we'll adjust the pH in the water from anywhere from 5.6 to 6.0. If it's a little higher or a little lower than that for germination, it's absolutely acceptable. Okay. All right, moving on. It's very, very important, as we talked about with the purpose of draining the oasis food, that oxygenation is very, very important. It's one of the most overlooked factors, especially seedling propagation. So what we want to do is we don't want to have a nutrient solution in the seedlings flowing all the time. What we like to do is we like to cycle our nutrient cycle. So a system like this, as you can see, is totally self-contained. It has its own tank and its own pumping system. So what we do is we will set a timer. So basically, the pump will come on in the morning, and it will feed the seedlings for 15 minutes, and then shut down and allow the seedlings to drain, which again allows oxygen to be drawn into the root zone. After that, midday, about 15 minutes again, it comes back on, brings in freshly oxygenated and fresh nutrient solution, and then shuts down after 15 minutes. And we do that 3 times a day. So we basically have a feeding cycle of 3 cycles per day of 10 to 15 minutes. That time is not super critical, but it is important to have a few irrigations during the day, but then a downtime also to allow oxygenation to occur. So that's one of the real important things we want to remember to think about with our propagation. Oh, one other quick question I get a lot from growers. Some growers who grow spinach or chard will sometimes have an issue with the seeds actually popping out of the oasis. If you notice, the lettuce usually sets and will germinate right out of the cube very nicely. If you've tried to grow spinach or Swiss chard, it will tend, as it grows, to pop the seed out. So what we like to do is take a wet sheet of paper towel or a wet sheet of just common newspaper and put it on top of the oasis for the first 1.5 to 2 days. Once germination occurs and the seedlings start pushing up against the bottom of the newspaper, we take it off. And that's just one little trick to help allows the plant to push its taproot down into the oasis cube. So just a little something. So that's the propagation system that we talked about. That's a lot of what people have asked about regarding propagation. Now, once we move into the main greenhouse, we have to look at utilizing our real estate most effectively. And that's one of the factors that growers ask a lot about. They ask about plant spacing and how many plants can we get in a greenhouse or how many plants per square foot. And what American Hydroponics has developed is PopTurn Technology, the use of a nursery channel and a finishing channel, which allows us to space the plants very, very close together while they're small, and then move them out into a larger spaced area when they get larger. And so a lot of people are very familiar with this system already and use it. Here's just a few things to think about to help, especially with growers who are growing in hot weather. When transplanting from the nursery channels, where the plants are grown at a very, very high density, when moving them into the finishing channel, it's very important to take them out. As you see with this basil, you see a fairly extensive root system. Especially in hot weather, growers, when they're putting the plant into channels, as you can see here, it's easy to damage the roots, and it's also easy to catch the roots, so when they go into the channel, they don't make good contact with the bottom. So what we do is we have growers with a small container of nutrient solution. And what we do is, as growers are going through and transplanting, they dip the seedling in the nutrient solution, which one will pre-charge the cube with extra nutrient, which will help, especially in hot weather, but it also will gather up the roots. So now we have very wet roots that are gathered together that will go in the hole very nicely. It's important to make sure that you get the cube centered in the ribs of the bottom of the channel.
Another question, Joe, that came in is if you're using propagation and you're just using water, when do you introduce the nutrient solution?
Well, that was a great question. The nutrient solution, once we're in the propagation system, they go into the propagation system, we're running a full strength nutrient solution in that. So after that initial fresh water dunk, everything is fed full strength solution. So once they're seeded, we put them right into the system.
You oxygenate?
that
Oh
reservoir.
yeah, someone asked about a stone.
You can use air stones.
Yeah.
That's not the most effective way to oxygenate. Essentially, the most effective method of oxygenation is agitation. Our systems are actually designed. If we go back here to the propagation system just for a second, our systems are actually designed. There's a space between the feeder tube and the oasis tube. So as the nutrient solution flows down, it actually takes oxygen from the environment and brings it in. And then as it's draining in the system, again, it's agitating. Think of a waterfall. Think of moving water. And what that's doing is that is actually pulling oxygen into the root system, into the nutrient solution, which then gets back to the root system. And this type of system oxygenates very, very effectively. With our main production systems, we actually go one step further and we install a Venturi into the plumbing system, which uses the natural flow of nutrient to draw oxygen from the atmosphere into the system. So if you think of a stagnant pond or a swamp, there's no moving water. If you take a waterfall and add moving water, the water is much cleaner, much better oxygenated. And that's one of the things that is done naturally. So our systems do that as well. We also get a lot of questions about controllers, the right type of testing equipment. To be honest with you, there's a lot of different controllers out there, a lot of different testers that work very, very well. A couple brands that we like to work with are AutoGrow and Hanna Instruments. These are very simple, very straightforward testing devices. What we want to do with our growing systems, we have a dosing system. I'll show that to you in a second. But the dosing system will adjust the pH in the nutrient solution all the time. But like everything else in a greenhouse, it's not infallible. So it's very, very important for the grower to always be involved, to know what's going on, to be able to test periodically and measure. So it's real important to have a handheld device like this at all times. Very, very simple, battery operated. You turn it on. Most have a probe that's attached. Others actually, the entire meter has a small probe on it. You dip it in your nutrient solution tank. You get a very quick readout of what the pH, the temperature, and the electrical conductivity or the strength of nutrient solution is. And at a very quick glance, you understand exactly what's going on. Changes in your nutrient solution could indicate issues like plant stress, or if a piece of equipment like a doser fails and it's not properly adding nutrients as needed, this type of testing on a daily basis will tell you. So it's a really, really important tool, very, very good to have. What are the other issues that growers...
And this one is just another version of it.
Yeah, this is the NutriTest, this is the AutoGrow, same exact device with a pH probe, and pH probe and an electrical conductivity probe. Same basic device. Now, with all the technologies that we use, it's very easy to fall into a habit of allowing the equipment to grow the plants for us, and that's a mistake. I've been a grower for over 30 years, and one of the big issues that I see is people not making observations in a greenhouse and waiting for something else to happen, like a piece of equipment to fail or to tell us something's wrong. So basically, scouting and being involved in your crops is very, very important. When growers are transplanting, I always tell the growers, as they're transplanting, it's very, very important to monitor the crops, find out what's going on, look through it to find very, very quickly when you're handling the plants, you'll see any evidence of insect damage, any types of diseases, anything like that. So that's very, very important to do a daily scout as you come into the greenhouse each day. Go through your crops, get to know what's going on. The students were just in today transplanting some of these crops. You see the chard here was just transplanted in. Very easy, a very good time to see if there's any issues with the crop, any problems. So don't wait for something to happen. Be very, very proactive. Spend time every morning in your greenhouse testing the nutrient solution, observing your crops. I always do what we call the walkthrough. So we walk through, we take a look at the plants. I always like to pull the plants out, take a look at the root systems, see what's going on. That will tell you a lot. The more that you can stay involved in your crops, the better off you are. So it's real, real important to be involved in your crops on a daily basis. It's also very important to keep the greenhouse clean. This greenhouse fortunately has a concrete floor, which is a little easier, but regardless of the floor surface of your greenhouse, it's very, very important. Once you harvest crops, inevitably you're going to drop plant debris, you're going to drop material. after you're done, take the extra 10 minutes, sweep out, clean it out. That will help keep insect issues down, help keep disease issues down. So that's all really, really important. Okay. One of the other questions that I get a lot is about crop scheduling. In an NFT system like this, we know we have a certain number of plant spacings. We have 10,000 plant spacings here in this greenhouse. So how do we schedule that, especially with multiple crops? How do we plant them out? So what we do, let's just use lettuce as an example. If we're growing lettuce for a specific market and we have 10,000 plant spacings, first thing is to determine your crop turn time. So in your given area, and we have some general guidelines that we can give you on that, but in most areas of the United States, utilizing this, it takes approximately 2 to 3 weeks from the time that a lettuce plant is put in the finishing system to harvest. So basically what we do is then take that figure and we work backwards. So if it's 3 weeks in the finishing system, we have 10,000 plant spacings, we divide that 10,000 by 3, and that will tell us our weekly maximum. So then we, from that point, then seed and transplant that corresponding amount every week. Most growers strive to have a weekly harvest of roughly the same amount of crop every week. So that's the best way to do that. Some of you may have a specific application where you want to harvest larger amounts every 2 weeks or every 3 weeks. Obviously, then it's very easy to kind of go backwards and schedule it out. But being able to precisely determine how many plants to seed and transplant and harvest every week, and those should be the same numbers. If you're seeding 5,000 basil plants a week, you should be striving to transplant and then harvest 5,000 a week as well. The goal with a system like this is to try to set it up for very steady, even production at all times. I want to talk about environmental control. This is one of the most overlooked portions of growing. It's very, very important to maintain an environment that's suitable for your crops. I know people that come into greenhouses and they look around and they say, gosh, it's hot in here, or gosh, it's kind of cold in here. If you're feeling uncomfortable, that's affecting your plant. Now, obviously, that's not the only parameter that you use, but if you're in an environment that is physically uncomfortable, there's something else that we need to look at. So with most crops, we've got a temperature range that we like to maintain. 62 to 64 degrees at night is the lowest temperature we want it to go. And then 70 to 75 degrees during the day is, again, optimal for most crops. Some crops might be more specific, but basically we want to be able to control that. So spending a little extra time, a little bit of extra money, and a little bit of effort on making sure that you can maintain those types of parameters is important. In a greenhouse like this, we have sidewall vents. This is a naturally ventilated greenhouse. So we have sidewall vents that open up. They're shut right now. You can also notice at the bottom of the vent, an insect screen that's attached to it. We want to have good airflow. So if you open up and the temperature rises, and the air then goes out through the top ridge vent. So we're just using natural convection of air. If we go to the front of the greenhouse, we can also see a controller. This is a step controller. It's a very simple, low-tech, but effective controller that operates all of our equipment. People ask, well, how about thermostats? Thermostats will work well. This is a one step up from that, and it does a great job of maintaining the environment. So we set in our environmental parameters, our temperature, our humidity levels, and it will adjust all of the equipment from our heaters to our vents to our fans to maintain those temperatures. So one of the more important things that we want to look at is maintaining a consistent, even environment. Days that are too hot and too cold, that tends to stress out the plants and will cause effects on your production. So we have more questions.
Yeah, so we have a bunch of questions here. One of them, growing herbs, basil example, and lettuce. Yeah, is there any difference in terms of the nutrient solution? Do you have to have different nutrients?
For high-level, large-scale production, we tend to like to alter or make a custom nutrient solution formulation very specific to that. If we have 5,000 square feet in sweet basil, another 2,000 square feet in cilantro, we may adjust the level. Cilantro tends to use a little bit more calcium. Basil needs a little more nitrogen and potassium, nitrogen and phosphorus, excuse me. So we tend to make a custom formulation. In general, for small to mid-scale production, one simple general nutrient solution is more than adequate for all herb crops. All of these crops, there's a number of different types of lettuce, culinary herbs and greens, all within the same system, very, very successfully. So you don't have to, when you go to large-scale commercial production, there may be some advantages.
What slope do we use on our channel, and what's the water flow?
Water flow, we have a slope of about 4 inches and 12 feet. And what we like to do is maintain somewhere approximately 1/2 to 1 liter of water or nutrient solution per minute flowing through the channel. The actual volume is not super critical. Anything less than 1/2 a liter per minute, and we tend to not get good oxygenation or sufficient watering. Anything over that, we tend to get sometimes some leaks or water running out. So that's just kind of the sweet spot, but the actual flow rate is not as important.
So these questions, what's the difference between TDS and EC, and do you have a specific pH or EC meter or that we use, or one that you can use as a beginner?
Yeah, most of the meters, as the ones that I just showed there, will measure TDS, which is total dissolved solids, EC, which is electrical conductivity, or CF, which is the conductivity factor. These are all the same figures. Basically, what they stand for is the actual ionic strength of a nutrient solution. So what it's telling you basically is how strong that nutrient is. And so with different parameters like EC versus ppm or parts per million, there's a different value, but the actual, there's a conversion that's the same. So basically what most growers will use is EC or CF. And EC, for example, for lettuce, we're running an EC of about 1 to 1.2. And then CF is just a factor of 10 of that. So that would be 10 to 12. Basically what we're looking for is an actual gauge of the strength. Too high or too low, and that tells us something is going on with our crop, or we may adjust for different crops. So by and large, that's our standard of measurement. And then pH, there's a pH question.
Just what meter do you use?
Oh,
and
the same
so we actually have our people coming in to work and do all their harvest and everything. So just a couple of last real quick questions. What's the room temp now? Do you wash the floor out from time to time? The greenhouse, is it polycarbonate or polyethylene? And so why don't you address those two? Room temp now,
Yep.
Floor washed out from time to time, and what's the greenhouse made of?
Okay, so
and then there's one more.
Yeah, the temperature here right now is approximately 70 degrees Fahrenheit. It's an overcast day. If the sun were out and it was bright and sunny, the temperature would be allowed to go up to about 75 to 77 degrees Fahrenheit before real serious ventilation would start. We're running between 55 and 65% relative humidity. This greenhouse here is a double wall polycarbonate. So this is a rigid material. There is basically 2 layers of polycarbonate plastic with an 8 millimeter airspace in between, which helps hold the heat in a little bit. Has good light transmission, allows the light to come through. Similar to 2 layers of flexible polyethylene, which most growers will use. Certain types of glass also work very well. There are pros and cons to each in terms of thermal capacity and price, so every situation is different. But for this application, the polycarbonate was the best.
And the last question before we go is, do you see any root growth difference between the water fed versus the drain end?
Oh, at the end, absolutely. Okay, that's a great question. So basically what the person is asking is if there's any difference in root growth from the inlet and the channel where the nutrient comes in to where it's going out. And no. And the reason for that is the flow of our nutrient solution, that's a big factor in that, because what can happen in certain systems, if there's insufficient flow, you can get a lack of oxygenation to the end. So oxygen is being used up by the root systems as the nutrient flows through the channel. Conversely, also certain nutrient elements can also be utilized and used up, which is why it's important to have a good flow and a good exchange. Our channels, for the most part, are 12 feet long. The flow rate and the length of the channel is designed specifically to allow a great exchange of both oxygen and nutrients. So the answer is no. The growth should be exactly the same.
Okay, so we're going to wrap it up just real quick. Someone asked about the vertical plants. Those are, we'll get to those another time. That's vine crops on that side, and those are tomato plants right there. But we'll address that at another time. So we'll wrap it up.
So thank you very much for your time. We would love to answer more of your questions. Most of these presentations will go much better and easier and be more directed to your needs. If you'll send us some input, so please do. we have on our website. Please go to amhydro.com. Take a look. We have a chat feature. Feel free to ask us questions. You can send emails to us. We have upcoming seminars. We have one coming up next week right here in the HCOE greenhouse. We also have an upcoming 2-day seminar in Pleasant Grove, Utah at the end of April. Please go ahead to our website and get information. If you're on LinkedIn, we also have a LinkedIn hydroponics forum. It's called Hydroponic Crop Production. Feel free to go and join. It's an open forum. You can post pictures. You can ask questions. You can send us a picture of your lettuce and say, hey, what's this insect? Or why is my lettuce turning purple or whatever? And we'll be happy to address them. So thank you very much for your time. And please feel free to continue to send us in questions. And we look forward to seeing you again real soon.
Very much.